book, Maths Part 2, Engineering. Scalar product. Angles. Nice. Okay. Right. Ready, Ed? Yep. Okay, so we're looking at angles. Between vectors. Can't quite hit the 9 o'clock, just a little too hard. Are you even in this building?
No.
Oh well, damn. Now I understand why. Okay. So here we want to try and find the angle between two vectors. So let's say here is vector A, and here is vector B, and we would like this angle here, theta. So let's prove the formula, and the proof at the end of the vector chapter we'll have to do some vector proofs. They like to ask some proofs in the exam, so it's good to practice proofs for vectors. So here's how to find the formula for the angle. We'll draw a vector from A to B, and we'll call this vector AB. And by using the cosine rule from semester 1, we can say AB squared equals A squared plus B squared minus twice AB, cos theta. So by rearranging this, we can get 2AB cos theta equals A squared plus B squared minus AB squared all over, then if I take this down, 2AB. Okay, so I need to continue, Ms. Sharif. There's more to the proof. So we actually, you can see here we have a formula to calculate the theta, but in fact we can simplify this, which we'll do in a moment. Have you got your lab book out now?
No.
I need it because I can't grade the coursework until I get the lab book. Okay.
Did you grade hard?
No. No, I'm going to wait until I have everybody's, because I don't like doing these things in two halves. I want to do them all together.
Did you have a look at them?
Didn't even open them. Like I said, you could have just given me 10 recipes for cakes and stapled the lab coursework on the front. Okay, I need to scroll down now. Let's continue. So, well, I'll just write here. We'll just call vector A x1, y1, z1. And we'll just call vector B x2, y2, z2. Okay? So, we get cos theta equals big fraction twice the magnitude of A times the magnitude of B, and then it's the magnitude of A squared plus the magnitude of B squared minus the magnitude of AB squared, and AB is B minus A, so that would be x2 minus x1, y2 minus y1, z2 minus z1. So now we're going to have to work out that big fraction here. This one will be x1 squared plus y1 squared plus z1 squared plus x2 squared plus y2 squared plus z2 squared minus x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared, all over twice square root x1 squared plus y1 squared plus z1 squared, square root x2 squared plus y2 squared plus z2 squared. Okay. Now we need to expand these three. X1 squared plus y1 squared plus z1 squared plus x2 squared plus y2 squared plus z2 squared minus x2 squared plus 2x1 x2 plus x1, no, hang on, no, hang on. Minus, there's a minus here, minus x1 squared, and then likewise for these two, so minus y2 squared plus 2x1 y1 minus y1 squared plus, I'll just write etc, the same for z. But you notice that you have some cancelling here, so x1 squared minus x1 squared is gone, y1 squared minus y1 squared is gone, z1 squared minus z1 squared is gone. Here you have x2, y2, z2. Oh look, there's another cancelling. x2 minus x2 squared, y2 squared minus y2 squared. This one will cancel one down here as well. So it looks like all you're left with are the middle pieces with the 2's in them, the 2x1, y1. I miswrote that, I should have written here, sorry. Yeah, y1, y2. And then the last one is 2, z1, z2. And because here there's a 2 down the bottom with the 2 square root pieces, this 2 will cancel all the 2's up here, and this is the same, and this is the same. And actually what you realise, these two together makes one of them squared. So the root is dropped. Oh sorry, no, they're not the same. This is x1, y1, x1, y1, z1, x2, y2, z2. So we don't quite drop them. So I'll just leave the roots here. So what we're left with is x1, x2 plus y1, y2 plus z1, z2. And I'll just write these back again as the magnitude. This is the magnitude of A, and this one is the magnitude of B. Do you notice what the top is equal to? Does it look familiar? Yeah, the dot product. So you're left with A dot B over magnitude of A, magnitude of B. But even that looks, I hope, familiar. Does that look familiar? A over its magnitude? Yeah, what's that called? Unit vector. So you get A unit vector dot B unit vector. So we end up with this very simple to write formula. The angle between two vectors is the cos of the angle between the two vectors is the dot product of the unit vectors. So it gives us some reason why the dot product is important, because when you dot product unit vectors, you've worked out the cos of the angle between them. Okay, so if you can write this down now, please.
That's the formula?
No, I would like you to write the proof down because vector proofs are on the exam.
All of this?
They don't tell me which proofs are on the exam, so it could be a proof of anything, even something you haven't seen before.
So anything.
But you should have been writing it.
No.
No. You'll have to get it from the video later. If I zoom out any more, it'll be too small to read.
Can you try?
Only if your classmates are happy with that. Classmates, are you happy with this level of zoom?
Yeah.
Yes.
You have this all written down? Yeah. You got it now? Okay. Let's have a look at an example just to get us started. Adnan?
Yes.
Okay. So let's pick something simple to start with. Let's say A is the vector 1, 1, 2 and B is the vector minus 1, 3, 4, and we want the angle between these two vectors. So using our rule, we have cos theta equals the unit vector A dot the unit vector B. So on the top we have A dot B, which is minus 1 plus 3 plus 8. And on the bottom we have square root 1 plus 1 plus 4 and square root 1 plus 9 plus 16. That's equal to 10 over square root 6 square root 26. Now I'll need the calculator and we can get the angle here. So that means theta is cos inverse 10 over root 6 root 26. Now there's actually two answers here. The reason that you could get two answers this is the acute answer, the smaller angle, but also you could have this bigger angle between the two vectors. So usually in the exam they want the smaller angle. So just let's imagine this, we call it is one answer on the calculator. Then this other answer here is 180 minus the first answer. So you often have two answers here, but they always want the acute or the smaller angle. So let's see. Does anyone have their calculator handy? Oh wait, no, mine's loaded here. Cos inverse 10 over square root 6 times 26. And I'm in radian mode. Let's go back to degrees, which is fine. You just have to give the answer as radians. 36.8 degrees. That's okay? A typical exam question, this is typical. A typical section A question, actually. Got that? Yeah. Okay. Continue? Yeah. Right, so look at this now. Let's imagine A is perpendicular to B. What does that make the angle between them equal to if they're perpendicular? Well, that means theta equals 90. Which means cos theta equals 1. Cos of 90 is 1. 0. Cos 90 is 0. Which means that A dot B over the magnitude of A times the magnitude of B should equal 0. Now, let's just say we don't have vectors which are 0 length. Because you know, the vector 0, 0, 0 has length 0, and we don't want to be looking at anything weird like that. So A and B here, these are not 0. So the only way that this could equal 0 if A dot B is equal to 0. So in other words, A is perpendicular to B if and only if A dot B is equal to 0. So in other words, if the dot product is 0, you know that they're perpendicular. If you know that they're perpendicular, the dot product is 0. This is a very, very useful result because it means you have a very easy way to check if vectors are perpendicular. You just need to check if their dot product is 0, and then you know. Yeah. Yeah? No. Has anybody studied this before? No? Okay. This symbol, by the way, is called if and only if. It means you go left to right and right to left. Okay. Scrolling down. Adnan?
Yes.
Musharif? Yep. Let me give you a small one to check. I want you to check if this is perpendicular to this. Check if they're perpendicular. We'll call this one A and this one B. Okay, what's their dot product? -2 plus 2 plus 0 equals 0. Therefore, perpendicular. Okay, let's have a look at some worksheet questions. Yeah, I think this worksheet is okay. If you just have a look at the moment, let's just have a look at some of the questions together. So, first question, I simply want you to use the formula to get the angle between two vectors. Just be careful with the first one. There's a k missing, so what's the k number? 0. So that was like my first example I did. Then the second one, I want to check if they're perpendicular. That's like the second example I just did. It's the third one that's a bit different. These three vectors make a triangle. I want all three angles. So what's happened here is I've given you three vectors, let's say A, B, C, and the vectors are like this. There's vector A, there's vector B, there's vector C. And they can form a triangle, which I'll draw in red. And what I want is the three angles of this triangle. So let's just call this one here theta 1, theta 2, theta 3. So how could I get theta 1? I could say cos theta 1 equals what? Who can tell me what that would be?
A equals B.
Over?
A the magnitude of A and B.
No.
A and B.
No. Thanks for trying though, but it's a little bit harder than the previous example.
N squared.
No. What's this vector here?
AB.
And this vector here? So it's AB dot AC over magnitude of AB times magnitude of AC. Because these are the two vectors you're getting the angle between. Right? So what about theta 2?
BA dot BC.
Yeah, BA dot BC over magnitude BA, magnitude BC. And then finally theta 3. Well, you could just say that's 180 minus theta 1 minus theta 2. Because it's a triangle. Okay. Be careful with that in the exam. This sometimes catches students out in the exam because they think, oh, this one is between A and B. But it's not. Adnan, if you did this one, cos theta equals A dot B over magnitude A, magnitude B, what angle were you actually finding when you did that?
The theta 1.
No, this is not theta 1. This is theta 1. This one is not theta 1. Does anyone see where it is on the diagram?
The angle from A to B.
Where is that on the picture? Top, bottom,
The
left,
red
right?
line.
Huh?
The red line.
No. The green line. Because this is vector A and this is vector B. This is the angle between A and B. That's the angle down there. That's what you would have found if you used that. Can you see that?
Yes.
Yeah. Adnan? Are you sure?
Yes.
You're not just saying that to make me feel better. No? Okay. So that's number 3. And then number 4 is actually not too bad. I want the angle between these to be 30, so what do I say? This dot this over magnitude times magnitude equals cos 30, and then you solve for x. My question is, what type of equation will it be? Linear, quadratic, cubic? Can you picture what you would get when you use the formula?
Linear.
No, I know why you said linear. On the top it's linear, but on the bottom? Yeah, it's what on the bottom? Quadratic. So this will form a quadratic equation, which means there's probably 2 answers for x. So there's probably 2 values for x. And if you think about it, that kind of makes sense because yeah, it could be a Q or obtuse, or if this is one answer and the angle is 30, then this possibly, I don't know, but possibly the second answer could be the vector, but just on the other side. I don't know, but I have a feeling that it could be that. Possibly. So I think it's probably for now good if you can do 1A, 2A, 3A, 4. 4 questions now. And then after you do those 4 questions, if you want, we can talk a bit about the assignment. Adnan, Musharif had some questions on the assignment, and I thought, well, maybe it's a good time if we work on it together in class if you want. So if you, after you finish those, if you want to go back to your room and get your laptop, you can. But if you can just try these 4 first. Let me just save this video.